Hi everyone, let's read the question together. A 0.48 kilogram ball is thrown with a speed of 8.8 meter per second and an upward angle of 36 degrees. What is its speed at its highest point and how high does it go? Instead of using kinematics, we'll use conservation of energy here. First, I extracted all the variables in the first sentence: the mass, initial velocity, and the angle at which the ball was thrown. Here's a picture that describes the scenario, and we have to find its speed at the highest point. Now, at the highest point, vertically, there is no speed. However, horizontally, it's the same speed as the horizontal component of the initial velocity. That's because there's no acceleration in the horizontal direction. Of course, vertically, we have a gravity pulling it downward, so even though the ball was thrown upward initially, the gravity will pull it down to the point where at the highest point, the speed becomes zero. Again, vertically, it's zero. So, horizontally, it should be constant speed throughout the trajectory motion. So we'll write Vx, our first goal, is V0, the initial velocity, and to find the horizontal component, we have to use cosine theta. So I substitute the V0 from the given and then write down the cosine theta, 36 degrees. And when you put the number into your calculator, you should get 7.11 meter per second. We have a 2 sig fig and we are only multiplying here. Therefore, you should round up to the nearest 10th digit. So, answer is 7.1 meter per second at the top of each trajectory. Now let's find how high the ball goes up. To find that, we first need to use conservation of energy. Potential energy initial, we'll call it 0 because it's easier to work that way. It's going to be 0 at the height where the ball was thrown. We do have a kinetic energy initially that will convert to the potential energy at the top of each trajectory. Now we are concerned with the change of y direction, how high vertically it can go up. So while the part A was concerned with the horizontal direction, here we're going to be concerned with vertical direction. But at the top of its trajectory, vertically, it's not moving. So we'll say kinetic energy in the y direction will be 0. The initial kinetic energy, we'll call that 1/2 mv. Now, we have to be careful here. Vertically, you gotta take the sine theta, the V0 sine theta, because we are concerned with the vertical component. And don't forget to square that. And the potential energy in the y direction at the top becomes mg and let's say delta y. The goal was delta y, so I'm gonna circle that and then just rearrange the equation so that the delta y is found on the left side of the equation and the rest should be on the right side. I'm gonna expand out our square to 1/2 mv0 sine squared theta, and then divide it by n and g. This way I can cancel out the mass, and ultimately you should have v0, oh I forgot square there, v0 squared sine squared theta over 2g. We just plug it in from the given. Remember, the mass is 0.48 kilogram, the v0 is 8.8, theta is 36 degrees. And when you put this number into your calculator, you should get 1.365, and the correct unit should be meter. It's time for us to check the sig fig. We are only multiplying and dividing, and I see that we have 2 sig fig here and 2 sig fig there. Therefore our answer should be rounded up to the nearest 10th digit. So the highest position from the height it was thrown is 1.4 meter. So in other words, the delta y should be 1.4 meter.